We have got a slight technical glitch. Normally I'd like you to see me because I've got props and things in the background, but today, unfortunately, you can't. But we'll make sure that in the next and the future upcoming webinars that we will make sure that you can see me. So, before we go on, I'd also like to mention with the question and answers, because of the high attendance, we've got, well, 50 people logged into this webinar. We're going to ask that all the question and answers are done by typing. You've got a question and answer box in the top left-hand side of your screen. You can ask questions, and at the end of every section, my colleague and our marketing guru, Andy, he will be reading the questions back to me at the end of each section so that I can answer them. So, who are ACE? Well, we've been established for 25 years. We're the first company to supply HDP and stainless steel flow control equipment in the UK. We represent the elite of the Dutch manufacturers. And the reason why we see them as the best is because, of course, in the Netherlands, 1/3 of the landmass and half of the population live below sea level. To show you the gravitas of this, Schiphol Airport is 7 meters under the average sea level. So they're a country that's been battling with the seas for centuries, and that's why they're very, very good at making sure that they can, well, to date, they're winning their battle with the sea. We have our own in-house project management and installation facilities, so we're not just a supplier of goods, we could also carry out installation and offer full turnkey packages. And we act both as principal contractor as well as subcontractors to many of the well-known tier 1 contractors. We have a bold vision in the fact that our vision is to protect people, property and biodiversity with innovative and sustainable solutions. By that, of course, we mean from water, flooding. It's not just about protecting and creating flood defences, as of course we've also got to think about the ecology that lives in the watercourses and make sure that they can pass up through their normal migration patterns. So we try and create very sustainable, very environmental solutions whilst protecting the assets and the infrastructure that we all rely on. We're very highly accredited. We've got all the accreditations that you'd expect of a company that can deliver £1.5 million plus contracts. We've got all the UVDB accreditations. We scored 100% across the board on them. Of course, the 18001 is to do with our health and safety. And we've got construction online membership, which is something that quite a lot of the tier 1 contractors appreciate. So today, with this presentation, what we're going to be focusing on is flow control. So by flow control, I mean penstocks, which you can see in the left-hand side of the screen. You can see the face mounted as well as channel mounted, tilting weirs, when to use a tilting weir, why the tilting weir has certain advantages over penstocks, non-return valves in the form of flat valves, and also the unique wire stop that we represent in the UK, and stop logs. So we can cover everything from the large to the small. On the right, you can see the wire stop. We hold these in stock up to 600 millimeters. And on the left, you can see a much larger flood defence. This is actually in Morpeth, which is just north of Newcastle, which this whole dam, it basically is over the top of the River Wansbeck. So the issue that they have in Morpeth, after a 1 in 100 event happened 3 years in a row, it kept on flooding Morpeth, and they realised that with more than 100 cumecs passing down the river, because it was completely concrete, with wing walls on either side of the river, it would overtop as soon as you get past 100 cumecs. So what they decided to do was upstream build an entire dam, which would act as a temporary reservoir. And the products we supplied, the penstocks, the big 3 by 3 meter penstocks, that can take 12.5 meters water column pressure, they start to synchronous or automatically close as the water level starts to exceed the 100 cumex, meaning that you'll never get more than 100 cubic meters per second passing downstream, and thus you create a large storage reservoir upstream. To give you a sense of scale, here's a picture of us installing the penstocks. You can see when you put people next to it how massive these things are. ACE didn't just supply the penstocks, but we also carried out the installation and offered a full turnkey package, supplying the full hydraulics, the HPUs, the cylinders, the cables, and electrical in terms of the control systems. That was extremely desirable to this particular contractor because they had a huge amount of earthworks to do. You can see on this photo the height of the dam in the background. All of that wasn't there in the past, so they've had to massive amounts of earth moving, construct a huge concrete wall, and they didn't want to manage a whole array of different contracts in an area which they're not necessarily specialists in. So they decided to work with ACE, where ACE led and supplied the full mechanical and electrical package for this project. So we'll start off with flat valves, after giving you a big taster of who we are. All of our flat valves are HDP in stainless steel. We can make them from 100 mil all the way up to, you can see the top left image there. They are some of the biggest that we've supplied, which are in the Lake District on the River Gilpin. They are 4.2 meters high and 4.6 meters wide, so really big ones. But you can see there that we're starting to use stainless steel ribs for the reinforcement rather than the typical HDPE. The valves on the right-hand side of the screen, they are for a pumping station. When you're using flat valves on a pumping station, it is extremely important to consider the flow rate through the flat valve and making sure the flap doesn't flip up over the top. So you'll notice on the top of the flat valve there is a stroke limiter. This protects the flat valve from being able to flip all the way over. And also something that not everyone considers is vacuum. Of course, the pump is lower than the outfall, so lower than the flat valve. And when the pump stops pumping, the water pulls back on the flat valve because it's trying to fall back through the pump. This can create suction, and that can shear and damage the flat valve. So if that's the situation, you need to consider whether to use an air valve, or what we quite frequently use is, we call it a breather pipe. It looks like a big snorkel. You basically put that on the flat valve and it allows the air to come back in the system to protect a pumped flat valve from any kind of shear stress as the water falls back through the pump. You can see the flat valves in the bottom left, there on the River Erewash. They're pretty significant as well, 4 meters wide, 1.5 meters high. So, HDPE. Why do we use HDPE for a flat valve rather than the sort of traditional materials, wood, cast iron, those kind of things, steel? Well, HDPE has got some incredible material properties for flat valves. It's light, it's a lot lighter than cast iron, which of course allows it to open much more easily. Less head difference to open, so therefore less head loss. It's also a lot easier to install. Of course, if it's lighter, the craneage, your lifting requirements, everything becomes easier and the whole installation becomes much more straightforward. The HDPE back frame, that can get put straight against the head wall. We use an EPDM sealing system, so you don't need to grout any of these as you would with the traditional cast iron. So it's a much improved material. One thing with HDPE, we've got the classic joke, which is the same as the Ford Model T back in the day. You can have it in any color you want, as long as it's black. And the reason for that is HDPE in its natural form is actually white, but when it hits sunlight, it kind of turns into a dust. It degrades, and that can cause microplastics problems. As soon as you introduce carbon into your HDPE, it turns it black, but it also makes it fully UV stable and prevents any chance of microplastics being able to form or come off the material. mean, you have to have something pretty abrasive to make this material create any form of residue that might go off. The weight. The weight is also great from an environmental standpoint in terms of everyone's trying to reduce the CO2 nowadays. And with the HDPE, it's a much lower carbon footprint. I'm going to demonstrate this with the 500 millimeter flat valve as an example. So on the left, you can see a typical 500 millimeter HDPE flat valve. In the center, a typical cast iron valve, and on the right is a stainless steel or could be mild steel, but you coat it. The reason that the stainless and the mild is actually heavier than the cast is more because of the design. So all of them are designed with a pipe spigot. You'll very rarely get them just as a flat. So it's actually the design that's making that one heavy rather than the material. What you end up with is, for the same 500 millimeter flat valve, HDPE only weighs 13 kilos. And then when you start going to cast iron, it's 65 kilos, carbon steel, 140 kilos, and stainless 144. Now, the kilograms of carbon produced per ton of material is not too different between HDPE and cast iron. You can see it's 0.8 kilos of carbon for a ton of HDPE, 1.26 for a ton of cast iron. The massive difference, however, comes when you look at it because it's so much heavier. So you produce less amount of flat valves for a ton of cast iron than you would with a ton of HDPE. So you can see that your CO2 per flat valve goes from 10 to 81. So nearly 8 times more CO2 is produced for a cast iron flat than a HDPE one. The stainless steel one's worse because the stainless steel has got a very high CO2 footprint on the material, which is why we try and use HDPE as much as possible and keep the stainless steel volume down. But so on some aspects, we need it for the strength. And carbon steel, whether you're looking at the virgin or the carbon or the more mixed with recycled materials, but we've taken an average. You can see that that's also an incredibly large amount higher than what you would have with HDPE. If HDPE is so great, why do some people still choose stainless steel? Well, we had exactly the same question from somebody in the Environment Agency, and they actually chose to run an experiment. What material is better? Because if HDPE is better, it costs less, it's lighter, therefore you get rid of the water quicker. Surely it's a no-brainer, but he wanted to make sure for himself. So this is a project on the River Severn, and the Environment Agency bought two 2 meter by 2 meter flat valves. On the left, you can see a HDPE one, and on the right, you can see a stainless steel fabricated valve. The picture on the right is, so these were installed in 2011, and the picture on the right was taken in 2019, so last year. So they've been in place for, 9 years now, 8 years, sorry. And you can see that after the inspection, they were both in incredibly good condition. They're both perfect, pretty much. The welds on the right one, you saw 1 or 2, which were starting to get a little bit of corrosion on there, but nothing to worry about, nothing that wouldn't be expected with stainless steel. But it just goes to show, why would you spend the money on the stainless steel when the HDPE is working perfectly and you get rid of your water quicker, therefore building up as much storage upstream. I wanted to show this slide. On the right, you can see the flat valves and just how light they are to operate, and why, particularly if you're looking at friendly pumping applications, it's so critical to choose HDPE. If with fish-friendly pumps, of course, it's no point getting the fish past the pump if it's going to bang its head on a big, heavy cast iron valve. So if you're using HDPE, it's light and therefore opens, as you can see from this image, all the way to 90 degrees, meaning nothing for the fish to hit its head on. Another alternative, which I'll come to later, is a wire stop, because the shape of the membrane in that particular product also means that the fish can get through in one direction without any kind of harm. Talking about fish and fish-friendly flat valves, we do have three different types. I'm not going to go too much into detail. We're going to have a series of webinars. I'm going to do one which is all about fish migration solutions that we can offer. But I did want to quickly skim over it while I had you here. And on the left, our reset flap valve. That basically, the fish-friendly flap is in the top of the door, and it's operated by a tidal cycle. That's one of the most robust systems you can have for tidal defences. We've got our side hung doors in the middle, and they're offering a hugely wide area for fish to get through. So if there's anywhere where it's draining just constantly, only a little bit, not too much of a head difference, fish can just swim through and through, all the way through it, not a problem. And on the right, you've got our classic pet flaps. These are great in freshwater locations where there's not too much wave action, because they're not quite as robust as the tidal options on the left-hand side. Just to quickly explain how the reset valves works, I've got this short animation. The image shows two of our bigger units at Cockabridge. They were 3 by 3 meter flat valves, good for 5 meters water column pressure. But what we've got here is, and in the bottom of the float is the product called a wire stop, which I'll be explaining later. So the wire stop basically allows water to go into the float in only one direction. So the flat valve operates as normal. When the tide comes in, it lifts the float, then floods the float. And once the tide goes back out, the water drains out of the float through the non-return valve and back into the sea, resetting it with air for the next tidal cycle. Here you can see, this is at Ross up in the northeast. You can see the float filling up with water, dropping shut. And then when the tide goes out, this is a quick animation of the wire stop, so you get how that works. So it lets the water out of the float, but obviously keeps it full of air as the tide is coming up. Got a huge amount of these types of valves, particularly in the northwest, the northeast, and along the south coast. We've got side hung doors. These are actually a favourite of National Resources Wales, but they're getting more and more of them for the Environment Agency as well, because they've got some huge benefits. Very, very low opening pressure, because of course the weight of the valve is taken on the hinges, but you can pass significantly large debris through these valves and never have to worry about debris getting caught, because the opening width is so broad. We've got these at Fairborn, for example, which is all the way on the west coast of Wales, and they've told us that also elvers are able to get in under the door, because the door creates a bit of a back eddy on either side, and they're running up the pipes. They're saying thousands and thousands of elvers are passing through these. This is some CCTV footage from Natural Resources Wales site, where they're using these flat valves, and you can see very clearly how easily the doors shut. Between 9 AM and 8 AM in the morning, they're shut. They're open for long periods of time. But with the CCTV, what they were finding was typically at most of their non-return valve sites, they were carrying out inspections at least twice weekly. So a lot of their critical non-return valves, they're going to go and visit twice a week to check the debris, isn't holding it open because it's got trapped between the door and the culvert. And they've grown so confident in the side hung doors, because the debris that can pass through is large, that they're only actually going to check these sites once a month. Like, that is a huge CO2 saving in itself. The fact that the operators aren't going and driving around to all these sites all of the time, and they're only having to go once a month to go and check it for maintenance, because you're so confident that the debris and everything's going to get through with very little problem. And from a fish passage perspective, it's absolutely one of the best, because salmon and sea trout can easily swim up streams because the velocity of water passing through the valve is so low, and that's all to do with the opening width being so wide. So flat valves do have some downsides. One of the biggest downsides of a flat valve is that they can, in sites where there's a lot of silt or sand, become pens shut. So silt and sand can rest on the flap valve, and eventually it becomes completely silted shut or silted open. One of the most common faults that we see, and that's not just with HDPE, in fact, with all flap valves. But we've got an absolutely amazing solution for that, and that's the WASTOP. It's an inline check valve. It's basically a polyurethane membrane. We also have silicone versions if you've got specific chemicals or anything in your water. But you can see as soon as the opening pressure or the water builds up to an opening pressure, it opens, and specifically it opens with a very pulsing flow. So it pushes the water, and therefore any debris that's either in the pipe or silted up against it easily gets moved. As long as your upstream head is higher than your downstream head, as the video is showing now, it will still operate. The fact that the WASTOP has got that little pressure on the outside of the water means it's pushing it through with much more velocity than what you'll see with a flat valve. A really great case study is this one. This is a 1.5 meter diameter WASTOP, which we delivered in Wessex for Wessex Water in conjunction with the council. This particular site had a 1.5 timber non-return valve on it. It was shale that was penning this timber non-return valve shut, and it was relentless. They were sending an excavator down there roughly once every 2 to 3 months, excavating all of the shale out of the way of the flat valve, only for it to completely backfill with shale again and pen the valve shut within the next 2 or 3 months. Of course, that's huge expense, sending an excavator driver down there so regularly. It's not good for the environment from a CO2 perspective. Of course, sending somebody down with a big machine to go and remove all of that. So what we did is recommend the WASTOP because of the fact that its opening pressure flushes everything away, so it'll get the shale out of the way. I'll be honest with you, Wessex Water was sceptical. We were convinced it was going to work, but it took a little convincing. But they had such a problem with the flat valve, they thought, you know what, we're going to give it a go. We're going to have a look. We're going to try this. So we put the WASTOP in. After 12 months, the excavator hadn't visited the site once. It was absolutely brilliant, completely solved the problem for the client. And on the back of that, he ordered a bunch more WASTOPs. These were some 1200s, but I think in total he ordered another 6 or 7 large diameter WASTOPs and various small ones as well. This is the kind of problem that I'm talking about. This is the opposite problem, where instead of the valve being silted shut, it gets silted open. This can happen because, of course, when there's not much flow trickling through the pipe, it's just kind of leaking through the flat valve. The flat valve will allow this leakage. But if you've got silt and sediment in your pipe or in the water that's traveling downstream, what you'll get is, well, the image on the left, it all settles out. The flat valve gets stuck open, it can't shut anymore. And you can see on the right, you put a WASTOP in, and because the speed and the velocity that the water passes under through the WASTOP, you can see that it's impossible for the sediment and the silt to pen up, therefore vastly reducing maintenance and vastly increasing your peace of mind. We've used this at large pumping stations as well. This is an Environment Agency project. Barking and Dagenham, there's 2 pumping stations called Gores Brook and Beam River. One of them has 3 1400 mil diameter WASTOPs, and the other one 3 1200. At Barking and Dagenham, they were originally looking at stainless steel non-return valves. They wanted stainless steel because it's a pumped application. They had faith in the material, but what they were nervous about, being Barking and Dagenham, was that they grow legs and disappear, if you catch my drift. Therefore, to prevent this kind of risk of vandalism, they thought, what alternatives are there? How can we hide any kind of fabrication? Of course, the WASTOP's perfect for that because you can slide it inside the pipe. Therefore, hardly anything's visible from the outside. It works brilliantly from a pump perspective. These have been installed for, I think, over 8 years now. Very successfully. Sorry, skip the video. This is a nice video showing a wire stop in action. This one's in the southwest at Markham Brook. Shows another really nice solution in the fact that the wing wall was too tight, and particularly at the bottom, the pipe was flush with the invert, so flush with the sill on the downstream side. So with the wire stop, we don't need to, it doesn't matter that it's flush, we can make very special flanges, as you can see here. With a flat valve, trying to make a back frame or a flange that would suit that would be very difficult. What you can also see here is the low closing pressure. As the valve starts to close, it closes with much lower pressure than the opening pressure. So you won't have as well, the depth of the water in your upstream pipe will not necessarily be the depth of the opening pressure, because of course it drains down to a much lower level in your pipe. Now we come on to penstocks. Oh, I've forgotten to ask Andy any questions. Andy, are you there?
I am, Martin. Can you hear me?
Yeah, I've been storming through this without asking the questions. Are there any questions?
Yeah, there's a couple. There's one that came in at the start that was in regards to Morpeth from James. It looks like the dam crest is higher than the actuators. Do they still operate if flooded?
Yes. So the dam crest is higher, and the penstocks are good for 12.5 meters water column. So they're actually designed to operate when the hydraulics are fully submerged. Yeah, so the hydraulics do go underwater. Well, they haven't so far, but if it needed to, they would.
Perfect. And the other question is from David. Do you have any comparative head loss figures for wire stop versus standard HDPE flat valves?
We do have those figures. There's quite a lot of information on our website, actually. If you go on our website, there's a whole area dedicated to wire stop where you'll be able to get all of the head loss curves. And for our flat valves, I don't think that information on the internet is yet. But if you drop me an email or to the info account, we certainly have that information and can send that on to you.
Perfect. Thank you, Martin. Yeah, that's it from me for now.
Okay. So, penstocks. We supply penstocks in HDPE and stainless steel. As explained at the beginning, we were the first company in the UK to do it, and our partners, KWT, are the founders of the material combination. So, yeah, we've seen a few things and tried and delivered lots of different interesting projects. On the left, you can see a penstock that I love to show people because it shows you don't need to have a specific head wall setup. If you've got difficult conditions, you can quite often design a specific penstock to suit it. So you can see with my mouse cursor, it's a flush invert. The level of the concrete is completely flat across the base of this one, but we can provide a flush invert ceiling penstock to enable you to keep that flush, to prevent you having to cast in a concrete nib or a sill, which you have to do with quite a few other designs. This side is wall mounted, so you can see it can be mounted into the side. However, on the left-hand side, that was a flat wall, so this is completely flush coming through. So you could make this left-hand side channel mounted. So just really nice project to show that we can be very, very flexible in terms of what we offer. These are some two big, 2 meter by 2 meter penstocks with a thin one in the middle for a sewage treatment plant. And on the right is the other end of Cockerbridge. So I showed you the reset flat earlier, and they were 3 meters by 3 meters, and they're taking 5 meters water pressure off seating. So the water can actually get theoretically to the crest here of the dam on the downstream side, and it's sealing on 4 sides. To explain the penstocks, there's really 2 main types of penstock, and that's the 4-side ceiling penstock, of which all these images you can see now are. They tend to be fitted to head walls, at the end of a pipe, at the end of a culvert, but they're fitted to something and they seal on all four sides, on all four edges. Typical applications are flood defences. This is Cocker Bridge once it's completely finished, where on one side of the asset, you've got the non-return valve, and should there be a problem or something happens to the non-return valves, or they get wedged open with a branch, for example, you've got the backup of the penstock, which always uses off-seating, because of course you're preventing the sea coming inland. This is also a nice case study to show what ACE can do here. We've also delivered, supplied, installed the full M&E. The only mechanical part we didn't supply was these lifting davits, and that's because they were already there on site for the previous NRVs. So, channel penstocks. Channel penstocks are where you've got a channel, tends to be a concrete channel either side. They're used heavily in the utilities industries to guide sewage water and things like that, but also in canal systems where the water levels tend to be more of, you're trying to control them rather than stopping a surge coming back the wrong way. So you can see in the bottom left are undershot penstocks. So these are penstocks that move upwards. So water passes generally underneath them. They can pass over the top. These in that particular image were designed to have some water pass over the top. And they also have a stop block put in the top so that they could alter between summer and winter levels. However, they needed something that they could raise up and flush large volumes of water downstream. And that's generally the undershot penstock's function. You've got the overshot penstock here in the middle. So that's a penstock which actually opens upwards, closes upwards, and opens downwards. What they're trying to do is allow water to spill or flow over the top of them all the time. So generally you're trying to regulate the water level upstream. So as soon as you lower that, you can lower your upstream level. You raise the weir, you raise the upstream level. And sewage treatment, they're used for skimming scum off the top of the sewage during the processing, because of course you can very accurately just take the top surface off with this kind of penstock. That's the huge benefit of this, is with overshot, you can be very accurate in your level control. Undershot, not so accurate, and that's because if you think the penstock's only open 10 centimeters at the bottom, the volume of water that you're allowing downstream is relative to the pressure or the depth of water upstream. So it's much more difficult to accurately work out how much water you're sending downstream with an undershot penstock than it is with an overshot penstock. We then have combination products. This is for the Port of Tyne up in Newcastle. This one's recently been moved into a new chamber, only last week actually, as part of their critical works. And you can see that we've actually put a penstock with a flat valve. So we've combined the two lines of defence into a single product. That's something that to date I'm only aware that ACE and KDT can deliver, but it's those kind of innovative solutions that are something that we're well known for. In the top left, you can see what we call a decos. That's a double leaf penstock. So it's a combination of these two penstocks that you can see at the lower, middle and bottom left. And how it works is you've got a top leaf which travels up and down, so therefore very accurately controlling your upstream levels. And then you've got the bottom leaf, which generally just sits on the floor, is closed. However, in a flood scenario, or if you need to lose a lot of water quickly, you can raise both of them up and out of the way. On the whole, they're almost become obsolete because of tilting weirs. I'll explain why the tilting weir is generally a better version than, or a better option than decos. But when you've got a site where the penstock is very close to a culvert, so you don't have the space for a tilting weir to drop into something, the decos is still, a very good way to go. And to give you a sense of scale of what we can do in terms of the channel mounted penstocks, These are up on the sort of Lincolnshire side of the Humber estuary. And you can see, yeah, these were about 4 meters wide by 4 meters, roughly that kind of size. And they basically are an emergency. If the Humber estuary gets a surcharge, they can close these penstocks and stop it from coming in any further. They didn't need to be four-side sealing, so you can see at the top this is open. But that's because we've looked at the tidal data, and basically the tide should never, not in a 1 in 1,000 year event, get above that level. So it was considered, and it replaced a gate which was slightly lower in the past. So it is a much improved gate. Now, the reason for stainless steel over materials such as mild steel, for example, is purely all down to maintenance. On our gates, there's almost nothing to maintain. The seals are all EPDM water lubricated, so you don't need to go and do any greasing. In fact, doing greasing on our gate seals is going to be detrimental. It's something you shouldn't do. It's not good for the seals. Just leave them be, and generally your gate's going to be better. In terms of the spindles, for the smaller standard penstocks, we use a polyacetal nut block. The polyacetal nut block means that you've got absolutely no maintenance, because the polyacetal, there's no moving stainless on stainless components, so there's no possibility of the material seizing. We try and, as much as possible, keep that no metal on metal movement philosophy on penstocks such as this sort of size. But with these sizes, the forces are too large to use a polymer nut block, so we do switch to bronze, and that will require some lubrication. But you can access all the parts that need to be lubricated from the top. It's not a huge amount of work when you're considering that you've got rid of a big steel gate that needs to come out every now and again, shot blasted, resprayed, all that kind of stuff. It's just, yeah, so much better for your long-term your long-term investment, so your total life costs. So tilting weirs. Andy, are there any questions about
this? No questions with that one, Martin.
Okay. So we'll move on into tilting weirs. So as I said, the tilting weir is basically gives you best of both worlds of an overshot and an undershot penstock. It allows you to have very accurate level control, because of course you're wearing the water over the top. But you can lay it, if you need it for flood alleviation, we can design it for flood alleviation, and you can lay them flat and get them out of the way, letting you pass as much water as you need downstream. We were the first company in the UK to introduce this concept. And once again, our partners, KDPT, were the first company to design or come up with this concept. So we really are the leaders in this type of tilting weir with the side sheet. The way it works is you can see the side sheet. That, if you imagine it as a gear, is one huge sprocket, which with a very small pinion wheel gives you a huge ratio, which means that they're actually very low torque to operate. And that's also part of the secret behind the design, because trying to remove torque is always what everyone's been fighting for. This is a classic example. This is Lilford. This is on the Mean system near Peterborough. On the left-hand side, you can see the old gate that we replaced. And so you can see the large structure. It's got a big counterbalance. So to remove the torque, or the force needed to pull that flat of the tilting weir up, the chain runs up over the top, and you've got a heavy counterweight on the other side. And that means that you can have a low torque, but it also creates a very big, not very aesthetically appealing structure on a canal system that people are trying to enjoy with their narrow boats. So switching to a tilting weir, you can see in the top right the sort of size of the tilting weir that we put in at Lilford in the image there. It means that we've removed all of that structure at the top, much cleaner lines to the canal. The boats can come past, they can hardly see or notice this tilting weir. Another important factor of this tilting weir is it's a full flow beam tilting weir. What that means is it can lay almost flat or halfway open, and it can take the full depth of the water course, and that's because it's used for flood alleviation. So in the Nene, when it's in flood, these gates will just open and let an absolute torrent of water to try and keep the canal level stable. And to explain what I mean by full overflow beam, at the top is what we call a full overflow beam. So you can see the water level represented by the blue line stays the same as the tilting weir from position 1 to 2 to 3 opens. What happens, of course, if you think in position 2, you've got a meter going over the weir crest, that is a lot of extra weight of water. That is a whole lot more force. And then at point 3, you actually start to also create a vacuum which pulls on the bottom of the door as well. The forces are hugely different to a fixed overflow beam. So a fixed overflow beam is at the bottom. You can see that we would call a 200 millimeter fixed overflow beam. So you can see as the tilting weir drops, it also lowers the water level. This is typically happens in agricultural areas where you've got winter-summer levels. You're trying to hold water back in the summer, let a bit more go in the winter. Most of the Dutch tilting weirs are like this because in Holland everything's so refined in terms of how they manage the water levels that they can do that. But in the UK, we need these as fluid alleviation models, and therefore the forces that we have to design these weirs for are much higher. It's important when you specify a tilting weir that you get this bit right, because if you specify, it needs to go 200 mil over the top, or there's any disparity there, you might end up with a product that's half the price, but it's not going to last twice as long. That's for sure. I'd like to talk to you a little bit about our engineering capabilities, and particularly with the penstocks and the tilting weirs and what we can offer. In terms of the engineering, KWT has invested heavily in new staff, also people and capabilities such as this, that you can see on the screen, which is called FEM, or Finite Element Method. We offer this generally as an optional extra, and the reason for that is it costs a huge amount of time to do, and therefore we wouldn't be competitive with a competitor who isn't doing this kind of engineering. We can engineer everything in accordance with the Euro codes 1993 to consequential classes 2 or 3. As I say, normally when you design a penstock, you take the static load from one side, you add a safety factor, and then you design the penstock to deliver that. Not that much emphasis is put on the frequency of the operation, the frequency of the loading to try and analyze fatigue analysis and that kind of thing. For your critical assets, you've got to think, am I protecting a field here, or am I protecting 200 houses in a village? Am I protecting just property, or am I protecting lives? And when you're protecting property, and particularly lives, it starts to become very important that you know the kit can do the job. And this is where our finite element method, and also all of the additional classification categories that we follow in accordance with Eurocodes, as well as then further in the factory making sure that all the welds are carried on to the required ISOs to match the Eurocodes. We then deliver a full report, and also if following the FEM the product needs adjusting, it gets adjusted. It just means you have product that you absolutely know is going to be good for either 50 or 100 years live, without question, been modelled, been tested, documentation is there, and the people that you're protecting, and probably property that you're protecting is being looked after in the absolute best way you can be. To give you a showpiece of what we mean by what we can do in terms of our engineering and innovation, I love to show this case study, which is Pembroke. So Pembroke is a power station down in the southwest of Wales, and they had an issue where hot water was spilling out over into the estuary, into the sea. And this warm water, as it wasn't quite cooled enough, was mixing with the bacteria and this bacteria created a huge amount of foam. Like I'm talking a metre or two depth of foam all down the coastline. So it didn't look great, and the Environment Agency basically said you have to sort this out. Now, I must say this foam is completely biological, not harmful, it's just an aesthetic thing. But the Environment Agency did tell them they had to do something. So ACE suggested to provide some penstocks that we could weir the water underneath, therefore removing the air. And when you remove the air, the chance of the foam, the reaction with the bacteria is less probable. So they liked the idea, they got it tested out, got it modelled, and they decided to proceed. Unfortunately for ACE, they put it out to the market, which we felt was a little bit unfair, but happens. And therefore we had to compete and take a look at how can we be really smart about this. When we started to talk to the power station, we realised that every day of shutdown, or every day the power station stops operating, there's £100,000 loss of earnings for every day. So we realised that it was so critical to try and keep the amount of days on the outage to a minimum. In fact, it was more important than the price of the product. Every way we originally looked at it was going to have a big sheet piled wall constructed to be able to create a dry area for us to work in and put the penstocks in. And that is indeed what our competitors all suggested. What we did was look on site and notice there were some big rebates. These big rebates were traditionally used for big stop logs, but we could harness that and create a jack and bolt system, which meant that we could send some divers in, clean the rebates up, lower the penstock into position, and then using the spindle that you can see on the bottom left photo, which connects to each one of these little gearboxes, the penstock would jack itself into the rebate and completely wedge itself into position. That meant that we could do the whole job in 5 when all of our competitors would take a month. So of course, yeah, the price of the penstock did become irrelevant because the savings on the £100,000 a day loss of earnings was just astronomical. We supplied and got the contract full turnkey as principal contractor on this particular job, including the electrics, control panel, and there was 4 4x4 metre, 12 metre water column penstocks and 2 6x4 metre penstocks. So in total, there were 6 great big penstocks that we delivered there. It was a really nice project. Stainless steel does have a limitation because it's manufactured in plate rather than steel, where you can get large profiles, you know, HEA beams, that kind of thing. There is a point where, yes, it wins greatly on the fact that it requires so little maintenance. And its longevity is extremely high because its corrosion resistance is high. Eventually, the price and also trying to get the forces passed onto the structure becomes easier and more cost efficient actually in mild steel. And a lot of people ask us, well, where is that line? How do we know what we should do in stainless steel and when we should move to mild steel? This is a perfect case study where we're at that line. So this was St. Germans. It's the UK's largest pumping station, second largest in the whole of Europe. And we delivered all of the flow control. So 6 4x4 metre penstocks, 6 4x4 metre tiered flat valves, as well as the stop logs on the upstream and downstream. The stop logs were mild steel, but the penstocks and the flat valves were chosen to be stainless steel, and that was, of course, the customer trying to get the best totex costs for the project. You can see, the scale of them. They're also taking huge forces. It's good 12 meters water column back pressure. But this is pretty much the line where, when it's much bigger than this, we really do need to be considering whether mild steel is actually a more total life cost efficient direction of travel. When that happens, ACE can still help you because we've got our other partners, which is the Janssen Benelboom. The Janssen Benelboom are a Dutch mechanical firm, which can basically, they make and manufacture large sluice gates, lock gates, big sets of stop logs. They can do everything once again, from concept design through to detailed engineering, also with the advanced analysis, the FEM, through to production, and then ACE would carry out the installation. We've got a really nice case study. Oh, Andy, do we have any questions?
Yeah, we've got one question coming from Paul Isaac. Following on from the question about submersible penstock actuator, do you retrofit such controls? We're considering automating an existing manual penstock, but the actuator would have to be fully submersible within a flood storage area and operable remotely. Is hydraulic the only option, or electric? Mains power is available at the site.
Yeah, hydraulic is an obvious choice. It was always what we used in the past. However, there is a new product on the market. It's from Alma, and Alma is one of our partners that we use for the actuators. We tend to use Alma or Rotork, but Alma has a submersible actuator, good for 8 meters submergence and operation. ACE has already used this at Port of Tyne, where we've got 4 penstocks which were installed under the quay. Couldn't put a pedestal above the quay because they need all sorts of transport, lorries, forklifts, that kind of thing to operate above the quay. So we had to come up with a solution to actuate the penstocks and yet keep everything below surface level. So we use these submersible actuators there. I think they've been installed for, must be nearly 2 years now, and we've got excellent feedback. They're operating perfectly, and they come in 2 parts. So you've got the submersible motor, and then you've got what they call an umbilical cord. So it's a cable which then comes back to the control panel, which you can put somewhere else. So that is not in your floodplain. The only downside of the electric actuator is there is no option for a hand operation. So you can't attach a hand wheel to it. So you are 100% reliant on that electric actuator alone. That's the only downside. While with hydraulic systems, you can pump systems still. So I hope that answers your question.
Perfect. Thanks, Martin.
No problem. Moving through to stop logs. I'd like to start from a recent project that we carried out in Dublin. Got a nice video, and this was one that ACE did for the Waterways Island, as the principal contractor. So we were responsible not only for the supply and install of the stop logs, but also all the dive works, the floating pontoon, the lifting, and we managed the whole project. What made this project quite challenging was the fact that normally with stop logs, you've got vertical wing walls. And this particular lock from the 1700s was curved. It's a round kind of shape. And the client, he wanted to make sure that he had a good ceiling arrangement, and also that the stop logs would move nicely. So he was keen to utilize stainless steel for the rebates. As you can see, we got the rebates in. We actually made a frame that could be put in place. The divers came back and cast a hole underwater. They cast the whole sill. Otherwise, the base of the lock was a sort of U shape to create a flat bottom for the bottom log to sit on. The outcome was fantastic. You can see from this video how well that it seals. When you consider that the whole bottom plinth was cast in by dive team underwater in quite turbid conditions, we're extremely pleased with the outcome, as is Waterways Island. So they're really big stop logs, 12.5 meters wide, 6 meters high, which we delivered there in Ireland. This is another interesting project, which we delivered in Sheffield. This is iCare. So we delivered this to Sheffield University, and what they wanted, they had a huge test tank. I mean, it's 30 meters long. If you look at the guy that stood here in the bottom right, well, in the top right image, you can see how small he is in comparison. They wanted to be able to create compartments for doing different types of pressure tests. and yeah, put different aggregates in, and they were testing loading on pipe works and things like that. So they needed a stop log solution that was incredibly low leakage rates and a robust system that they could move around once every 3 to 6 months. The most challenging configuration is when the stop logs are all in a row and you split the tank left to right, which is why we have to build all this steel structures, steel works to get that right. Project, it was further complicated, should we say, because after the tank was cast, the wing walls weren't quite plumb, and we were working to tolerances because of the sealing rates of plus or minus 2 millimeters, which on a 6.5 meter width then is not a lot. You can just see the banana shape of the wall. Luckily, because we do like to see ourselves as innovative and willing to work with the contractors and willing to come up with solutions and solve these problems, we actually suggested ways of mounting them with a support frame. So we provided essentially a jig, and that was to make sure that the channels, wherever they were going to be cast completely plumb. Then the contractor could come in and pour the grout behind the channels, cast them completely in place, and therefore we could get the tolerance right, even though the walls weren't quite perfect. There was some real teamwork because the contractor needed to do the maths to check that the wing walls take the shear and things like that. But ultimately, delivered a really nice project that the university is using at the moment to carry out some really interesting research. This is on the River Dee in Chester, and this is to prevent surcharge. So the Environment Agency were looking for some stop logs, and they built this new wall you can see here, and that was because the Dee had backed up before at a higher level than the canal. So of course the water just runs up all the way through the canal, overspills and spills the whole area down there. So these tidal events are quite predictable, and they wanted a set of stop logs that they could go and deploy, a day or two before these tidal events happened. You can see here as well, originally there was a rebate in this concrete of the side of the channel, which was for a ladder. Upstream there were some ladders as well, so we felt from access we could potentially remove that ladder and put in a steel frame, which is then fitted with jacking bolts to put the sides of the rebates in, therefore keeping the canal completely flush, meaning that boats can still travel up and down without any risk of materials protruding into the watercourse. That was actually part of the job. That was one of the main reasons we were awarded the project. The second part was obviously moving these stop logs. You don't want to have to lift in 6 different stop logs onto the back of a lorry, take it to site, lift off 6. So we created a storage rack, which also doubled up as transport. So you could just lift 4 logs onto the back of a HIAB at the same time. And this shows you more the sort of larger, so the bigger capabilities that our partners, Jan Svenenbroek, can deliver. This is on a brand new build canal in the Netherlands called the Maximina Canal, named after the Dutch princess, well, originally Argentinian, she's now Dutch. And this particular project, originally the big challenge here was the pointing doors or lock gates needed to work on and off seating. Because the one side of the canal was tidal, sometimes the level in the canal was higher than the tidal side, sometimes lower. Now, typically how you do that is you construct 2 sets of lock gates in a sort of, if you looked at it from plan view, in a diamond shape. So you actually end up with 4 leaves at each side of the canal. So in total, you end up with 8 lock gate leaves, if you like, which is, a huge amount of infrastructure, lots to go wrong, lots to install, expensive. The way they picked this up, Jan Svenenbroek, was, can't we do it with a single gate? So if you look at the construction here, the one single 150-ton lock gate, and it seals both on and off seating. So you can see the arrangement here with my mouse. I'm circling. These 2 are locking mechanisms. So when the gate is shut in that direction, these 2 locks clank and lock the door completely shut, meaning that you can take the off-seating force. By doing that, this lock only has 2 leaves instead of 8. So it was, yeah, for the data staff in Holland, it was quite an easy decision to make once this innovation was presented. Quickly, just to round off the presentation, thought I'd let you know, ACE don't just do flow control. As I said at the beginning, we're going to be doing a series of webinars. So we're going to be doing a WASP-specific webinar, a pumping station webinar looking at our fish-friendly pumps, both the Archimedean screw and the axial flow. And the project in the middle bottom, that's Kiwi, that's our current largest live project. So for us, that's got a value of over £2 million. 6 4-cubic pumps being delivered there with a total of 6 meters head. On the left, you can see a weed screen cleaner. And also, I'd like you to know that the products that we talked about today, the flap valves, the wire stops, the penstocks, all of the standard sizes, the drawings are available on our website. We have them in stock. You can get them still. We are sending out stock from our warehouse. So if you need anything up to 1 meter in terms of flat valves or penstocks, or anything up to 600 millimeters per wire stop, it's available. And of course, I've talked a lot about our turnkey services, but yeah, our management services and installation team that we have in-house, they're so used to installing these kind of kits. It can offer a lot of peace of mind. They install penstocks, yeah, not quite every day of the week, but not far off either. So a very experienced and good set of team that we can that you can employ, yeah, for your project. And finally, any last questions, Andy?
Yeah, we've had one come in from Mark. In addition to FEA, do you perform CFD, e.g. for penstock, gate forces, silt and sediment movement, or transient free surface modelling?
In terms of CFD, we do perform CFD with our pumps, but that's specific for our pumps. We wouldn't do it necessarily for a penstock project or anything like that. I do have some partners, Mark, if you want to send me an email, I do have some partners that I can put you in touch with that would be able to help.
Perfect, thank you, Martin. And there's one more from Jonathan. Do you supply GRP, FRP, tidal doors, stop logs, etc.?
GRP, FRP, tidal doors. In terms of the GRP, we can do the lock doors. We can supply. We can even make lock gates in GRP. In fact, our partners Janssen Venable Spee have just constructed the world's first biodegradable composite rotating bridge, and so there's really some cutting edge stuff going on there. So yeah, that's all possible.
Perfect, thanks Martin. And that's all the questions. That's it for me. Thank you everybody for attending. I'll let Martin close off for you now. Yeah,
no, following Andy. Thanks a lot for attending. If you do have any questions, don't hesitate to give me an email. My personal email is martin@aquaticcontrol.co.uk. Also, the info email is on there. Yeah, hopefully we will be sending you links for some future webinars for you to join in on. Hopefully it was, yeah, you thought that was interesting and offered something useful for you today. Thanks.